Welcome back everyone. Good to see you back after 2 months. Anyway, let's begin with our topic. The James Webb Telescope. On December 25, 2021, NASA launched the James Telescope, a telescope. The first images from the Webb Telescope were released on July 12, 2022. The Webb Telescope was the Hubble Telescope's replacement. The major objective of the Webb Telescope's launch was to look farther into space than the Hubble Telescope could. The approximate 5 to 10-year mission of the Webb Telescope. NASA claims that the new telescope outperforms the Hubble Telescope by over 100 times. When comparing the mirrors of the two telescopes, we can observe that the Hubble Telescope has a diameter of 7.8 feet, 2.3 meters, while the Webb Telescope's mirror is 21.3 feet, 6.4 meters, in diameter. That's a 2.7 times difference. Hubble's photographs capture not just galaxy systems but also a record of the evolution of the cosmos. Hubble allowed researchers to take a closer look at galaxies that were formed 400 million years after the Big Bang. The James Webb Telescope may be able to close that distance and show images from 250 million years after the Big Bang, bringing us closer to the instant our universe began. The cosmos was largely shrouded in some form of primordial gas before the first stars began to shine, which is why this period is known as the Cosmic Dark Ages. The first galaxy's illumination, according to scientists, is what helped clear the cosmic haze. But they expect to have a better grasp of this fog with the aid of the telescope. James Webb will primarily capture photographs in the infrared, which will provide more detail about the objects in those images than ever before. The Hubble Telescope takes images mostly in ultraviolet, visible, light. Due to a phenomenon known as redshifting, in which light is stretched as it arrives and vanishes, leaving a red trail behind, scientists may be able to peer into incredibly old galaxies using infrared photography. Webb will be able to photograph extremely ancient galaxies that are presently being pushed distant from Earth and turning redder with infrared. The James Webb Telescope will be millions of kilometers from Earth, or nearly 4 times the distance between the Earth and Moon, whereas Hubble was just 547 kilometers distant. Humans would not be able to maintain James Webb if anything went wrong, although engineers were able to do it with Hubble after discovering a problem with its mirror not long after launch. Simply speaking, the James Webb Space Telescope will either work or it wouldn't. We're definitely counting on the former to see all the magic stored in our universe. James Webb's mirrors are really composed of beryllium, despite the fact that they look to be gold. It's true that each mirror has a gold covering, but it would have been disastrous to make the mirrors totally out of gold. No, not because of gold's extremely high density or malleability, both of which it unquestionably possesses. Thermal expansion would be the main issue. Gold expands and contracts significantly with slight temperature changes, even at extremely low temperatures, which is a deal breaker for the material of choice for Webb's mirrors. However, on this front, beryllium excels. You can guarantee that there will be defects in the mirrors at room temperature by chilling the beryllium to cryogenic temperatures and polishing it there. These imperfections will vanish once the mirrors are cooled back down to operational temperatures. The gold coating is put on after the beryllium is produced and shaped to its final form. Less than 2 ounces worth of gold totals just 48 grams in the James Webb Space Telescope's mirrors. The 18 mirrors used by James Webb must each be very good at reflecting the infrared light that it is intended to study. The appropriate quantity of gold must be used. If you use too much, the gold will start to expand, contract, and distort as the temperature changes. If you use too little, the mirror won't be completely covered. Vacuum vapor deposition is the method used to apply the gold coating. You inject a little quantity of gold vapor inside the vacuum chamber after setting the blank mirrors inside of it. The back of the mirror and other areas that don't need to be coated are covered with masking tape so that just the polished, flat surface is covered in gold. This procedure is repeated until the gold is just 100 nanometers thick, or around 600 gold atoms thick, as required. The mirrors of the James Webb Space Telescope include a total of only 48 grams of gold, while the uninteresting rear sides have struts, actuators, and flexors attached to them. An internal solar array powers the Webb telescope. Additionally, it contains a propulsion system to keep the observatory in its orbit and orientation. For the duration of the mission, the solar array will provide 2,000 watts of electrical power, and there will be enough propellant on board to support science operations for at least 10 years.